For the test, you can use the unit circle chart. Okay, make sure bring one. I've already posted one for you. That would be very useful. Otherwise, you have to do all the problems yourself. So even in calculus, we let you use it. So when you use this unit circle chart, okay, remember we talk about how we're going to work with this one. This is going to be, okay, this is cosine. Okay, and this is going to be the sine, if you like, and use the unit circle. Okay, so any of these points, okay, any of these points would represent, okay, for the angle, the first number would represent cosine of the data, and the second number would represent the sine of the data. Okay, so for example, if you look at this one, the angle is 30 degrees or pi 6. Pi 6. So the cosine of the pi 6 is radical 3 over 2, and the sine is 1/2. Okay, so the first number represents x-axis. Okay, x-axis is going to be cosine, and the y-axis is going to be sine. So write a note for yourself so that you're not going to miss it. Or for example, if you are looking for example, for an angle whose sine is going to be negative 1/2. So since you are looking for the sine, you may go with the second component, okay, to find it. So for example, you find one for here, negative 1/2. In this case, is going to be, you see the sine of 210. And you usually get 2. If you go around, you will get, okay, you will get another one over here, which is going to be 11 by 6. So these type of interpretation are such an important, it's such important in Calculus 1 if you want to take that course. And in practice, it's useful for you because you have to use this one. Okay, so let's make sure that you are ready for it. The first component would represent the cosine. You know that because xy. X coordinate would be the cosine, and the y coordinate would be sine. So be quick to be able to find these numbers for us, okay? So for example, if you want to find what is going to be sine of 135 degrees, this is 135. 135, and this is the coordinates. So the first one is cosine. Cosine of 135 is negative radical 2 over 2, and the sine is radical 2 over 2, okay? And we already talked about it. So if the angle is going to be terminated in the first quadrant, you know, the cosine positive, sine positive. If you are going to be here, for example, the sine would be negative, cosine positive. These are going to be very, very useful for us. Okay, any question? Now, in reference to use these type of ideas, we are going to, you see, you have these famous one. So sometimes you may have a bigger one or something similar to this. So the properties are going to be, they're going to define something that we call it a reference angle. And that reference angle would help us quite a lot. Okay, a reference angle and this table together would help you quite a lot. What is going to be a reference angle? Okay, let me just write it down and explain it. That is very popular, very useful. So it's, it's part of that section, the last section that we checked, which was 3.4. Yeah, it's, it's in 3.4. You have a couple of problems, and we are going to use it quite a lot. Okay, so let's give you this definition because we are going to use it tonight. Since you use this table, even without the reference angle, you'll be defined. But there are something else that we are going to do in future. So that would be very important to know these type of angles. Okay, so what's going to be reference angle? Reference angles. Reference angles. You see, when we consider an angle into the in a standard position, you see, look at this this angle. So this is the XY plane. Okay, this is going to be the XY plane. And suppose this is going to be, okay, this is going to be an angle that you're going to have. Okay, look at this angle. This angle is going to be theta. You know that this is going to be the initial sides, and this is going to be the terminal sides. Now, this terminal side, you see the terminal sides? The angle is going to be between this positive part of the x-axis and the terminal sides. Okay, this is going to be an angle. But there is going to be another angle here. You see, look at this angle. This is a terminal sides, and this is again what? This is again is going to be the x-axis. So there is going to be an angle, acute angle, between the terminal sides and the x-axis. This angle, I'm going to denote it by theta prime. This angle is called reference angle of the data. Okay, so the reference angle of the given angle is going to be an angle that's going to be formed by the terminal sides of the given angle and the x-axis. This angle would be very important for us because the behavior of this angle would be exactly the same as the behavior of the data. So if you want to talk about the sine of the data, you can consider the sine of the reference angle, the cosine, the tangent, etc. So especially when the angle is big, that would help us quite a lot to get these type of numbers. Okay, so look at this one. This is the one that you have. Okay, so for example, look at the angle 135. So the 135 would terminate here. The leftover 135, and this is 180. The leftover is 45. You see the leftover is 45. So everything of 135 is like the 45. Except we got to be careful. You see, it's in the second quadrant. So the sign is positive. So the sine of 135 and the sine of 45 is the same. Radical 2 over 2. Cosine of 135, since it's in the second quadrant, the cosine is negative. So the cosine of 135 is negative of the cosine of the 45, which is negative radical 2 over 2. You see, that's very useful. We'll be able, although you use this table, but that gives you some idea of what's going on with this type of angles. Okay, it's going to be the same. Look at this one. This angle is 220. So this is 220. That's a terminal side. That's a terminal size. The angle between the terminal size and the x-axis is this portion over here. Remember, this is 180. So to get to the 210, this is 30 degrees. So everything of the 210 is like the 30 degrees, except you see the cosine is negative and the sine is negative. So what's the sine of 210 is negative of the sine of the 30 degrees. The sine of 30 degrees is negative one half, so that would be negative 1/2. The cosine of the 210 is negative cosine of the 30 degrees. Cosine of the 30 degrees radical 3/2, this is negative radical 3/2. You see, very useful idea. And we are going to use it for some other purposes. To calculate, you have this table, okay, but we are going to use, we reference this angle quite a lot. So let's give a definition of a reference angle. Official definition of a reference angle, okay. So this is it. Because later on we are going to solve, equations containing this trigonometric function, and there are some other things that would be connected to this idea. So if theta is a given, okay, is going to be a given, okay, a given angle, and the given angle in its standard position, okay, standard position is going to be a standard position, then what we are going to have, it's reference angle. It's reference, okay, reference angle is going to be, is the acute angle, of course. The acute angle, I'm going to call it theta prime, formed by that terminal side, formed by the terminal side, by the terminal side of theta, and the horizontal axis, and the horizontal axis. Okay, this is called reference angle, because everything would be to the reference angle. When the angle is getting bigger and bigger, we shrink it. We shrink it by the reference angle. Okay, so this is going to be, I've already talked about one of them. Okay, so let's have an example. Okay, example. We want to find the reference angle. Okay, the reference angle of each given angle, if you like, of each given angle. Okay, the reference angle. The first one. Okay, the first one, for example, we want to find the reference angle of theta equal to about 200 and okay, 213, for example, degrees. Okay, 213. This is it, solution. You can graph it to see it. You see, in order to get to the 213, you have to go 180, and continue to get to the 213. So you are going to be here. You see, it's 180. So you need what? You need 33 more to get to this part. So this is the angle 213. Now the leftover. You see the angle between the terminal side and the positive, and the terminal side and the horizontal axis. This is going to be the angle in question. Remember, this angle is obtuse angle, so the reference angle must be an acute angle. So that's why we pick this one. Okay, so this angle, the red one, is going to be your reference angle, and you can give us the reference angle. So the reference angle is going to be what? It is okay, the leftover of is 213, if you like, minus 180. So the result would be 33 degrees. Okay, because you got to the 180, then you have to move to get to the 230, if you like. Okay, and these are going to be different format that we're going to have. Any question? I'll give you another one. Okay, the other one is, suppose you want to find the, okay, you want to find, let's say, how about 330 degrees. If you want to get the 330 degrees, this is going to be the one that we're going to have. 330, you know that 90, 180, 270, you are going to be here. Okay, so this is 270, another 30, another 30. So this is how much you travel to get to the 330 degrees. Okay, so this is going to be your terminal side. Okay, this is going to be your terminal side, and the acute angle between, okay, this is 60. Okay, it's going to be 60. So The acute angle is going to be this one. It must be a little bit up here because it's 270 and 60. So that give you the one. Okay, so in this case, your data prime is going to be okay, it's going to be 360. Okay, 360 minus 330, which is going to be 30 degrees. Okay, so that's going to be different format that you can have for this type of angles. So it would be useful to use the reference angle to get these properties of this function for future that we're going to have. Okay, so as I told you, the advantage of the reference angle is going to be, this is on the, because you are going to use it here. Okay, quickly, you can find the sine and the cosine by looking at that leftover that you're going to have. Depends on which quadrant are going to be. So that give you and that give you the result. I'll give you one example to see how I'm going to apply this one. Any question? You see quite a lot. Again, since you have that table and we let you use it, so you are fine. So for example, this is going to be an example. We maybe ask you to find these numbers for us. Okay, find.
Professor, I do have one question.
Yes.
Do you only have a reference angle if the original angle is over 90 degrees since it's acute?
Yeah, yes.
Okay,
Yeah, because
cool.
when it's going to be, yes, that's a good question. When it's going to be less than 90, the acute angle and that, both of them are going to be the same.
Okay, thank you.
Yeah, okay. So this is it. So for example, if you want to find the exact, okay, again, exact value, some of you missed it on the test, no calculator, just using your table. Write everything, if it's a radical expression, write it down in radical expression, okay? Find the exact values of, of the trigonometric functions. Okay, trigonometric functions. Okay, the functions of the following angle. You have a number of them in your practice one, PQP one. Okay, so be careful. But since again, using this table, you'll be fine. Okay, so the first one, for example, part one. Okay, you may be given 225, you see, 225. Again, you can go to that table if you like to get these numbers done, or you can, I just wanted to show you how you do it with a reference angle, okay? But you are free. On the test, you are free to do whatever method you feel comfortable. Okay, I'm going to use the reference angle, you see. I'm going to locate it first. This is 225. So this is 180, so I have to go 45 more to get this one here. So I'm going to be here. Okay. So this is it. So this is going to be the angle at 225 degrees. Okay. And the acute angle is going to be this one. You see the reference angle? So the reference angle, if you like, is going to be 45. And so you can write this one. So you can say that, oh, 225 is the same as 180 plus 45. You see, this is the way you can think about it. But your angle is in there, okay? You are where? You are in the third quadrant. When you are here, you see the sine is negative. The sine is negative, cosine is negative, and the tangent is positive. So what you can do is you can use this reference angle. You can say that the sine of the 225, first note that 225 is the third quadrant, is going to be negative. Negative of what? The sine of the reference angle, you see? minus the sine of 45. 45 is radical 3 over 2. So that's going to be radical 3 over 2 and you're done. Okay, because you are here, your angle terminated here, so its sign must be negative. But it's the same as the reference angle, which is the 45. Okay, any question? And it's the same for the cosine of the 225 is the negative cosine of the 45 degrees, which is again radical 2 over 2. Again, you know, you have it on the, you can use this one also on the test. This is 225, and you have both of them already. Be don't mind. It's nice to know. And the rest, you know, that you just divide tangent of 225, and you divide these two, so that give you, or again, tangent of 225 is positive. The tangent is the same as the tangent of the, okay, that reference angle. And the tangent of 45 is equal to 1. And quickly you can identify, you know, identify the other ones. And then you're done. Okay, any question? So just identify these three. So this is how you can use it quickly to get, you know, to get these numbers. Okay, I give you any question. So these are various options that you're going to have. So the next one is, okay, be something bigger. Let's have, how about 315 degrees? Again, 315 degrees is on the table. You can check it, but I want to show you how you do the reference angle things. Okay, so this is going to be the one. Okay, 315 is going to be bigger than 270. So that's a 90, 180, 270. So we are going to be here. So is going to be what? It's going to be 270 and 45 again. Okay, so that take us here again. You see that take it here. So this is it. So the terminal size, you know, it's the same angle because it's the 45 and the 45. So you can claim that, okay, your solution is going to be, so 315 degrees is going to be 2 pi, 360 degrees minus pi minus 45 degrees. Again, you are in the fourth quadrant, so the cosine is positive, the sine is negative. So when you want to check the sine of the 315 degrees, it's going to be minus the sine of 45. Again, which is a negative radical 2 over 2. Okay, and the cosine of 350 degrees is going to be, the cosine is positive, so it's exactly the cosine of 45, which is radical 2 over 2, and the tangent, positive negative is a negative tangent of 45 degrees, which is equal to the negative 1. And if on the test you've been asked to find those 6, then you'll be able to identify all the 6. I just want to give you an idea of what's going on with these reference angles. Okay, any question? So that's very useful to get these numbers. You know, if you want to do classic trigonometric function, then you have to take care of this type of idea as is. Okay, now we are going to get a couple of more properties of these functions that will be useful for us to go on. The one property that you see, if you go around just as usual, okay, these and counterclockwise, you know that the angle is going to be all positive. But we may use negative angles as well, okay? So for the negative angles, you can, okay, you can get a similar results, or you can use just take a formula for all of them, okay? My camera is, it seems to be all right on this side. That's the best I can have for the cameras.
Yeah, your camera's fine, Professor.
Fine, yeah, because that's going to be fine. Okay, so what we are going to do is let's check some properties of these functions. These properties very useful for calculus, very useful. And we're going to check all of them. So in order to take care of these negative, okay, negative angles, we have to borrow something from algebra. Okay, from algebra, we can have odd functions and the even functions. Okay, so what is going to be odd functions? Odd and even functions. By that we mean trigonometric functions. Okay, functions. This is it. Okay, so we just recall the definition of the even and odd functions from calculus, and then we are going to tell you which one is going to be which over here. So recall that. Okay, from algebra, recall that. Okay, recall that a function, okay, a function f is, okay, it's going to be even if, it's going to be even if f of, let's say, negative data is going to be f of data. Okay, you change x to the negative x in algebra. If everything is stay the same, the function is going to be called even function. Even function. Okay, so f is an odd function, odd function if f of a negative data is going to be negative f of data. Okay, so that would be even and odd function. You know that these are going to be symmetric property that we usually use. Now, how about in trigonometric function, especially those sine and cosine that we're going to be interested in? You see, look at this one. So this is going to be a kind of xy plane that we are going to have. Okay, so remember the way we define those sine and the cosine. I can use the unit circle, which is going to be easier, or just the same one. Remember that first. If you take this point here, let's have a circle. That would be better. So if this is going to be a kind of a unit circle that we're going to have, okay, this is going to be unit circle. And suppose I pick an angle here. So if I pick the angle theta here, this is going to be the angle theta. And you know that in this case, this is going to be the sine. Okay, so this is going to be the sine, and this is going to be the cosine. You know that this is x and the y. This is x, and this is y. And so basically, this portion over here, okay. So this portion over here is going to be your, this portion over here, which is the same as here. So y would be, if you like, the y would be the sine of the data. Okay, y would be sine of the data. And then the red one over here, okay, this portion is going to be what? X is going to be the cosine of the data. Cosine of the data. Now, if you want to identify the negative data, so this is going to be data. Remember, the negative data is going to be in this direction. So this is going to be negative data. Okay, so that's represented by the data, and this is represented by the negative data. Now, if you want to find the sine and the cosine again, you see, look at this one. So in both cases, the cosine would be the same because this is going to be the cosine of, okay, this is it. So this is going to be the cosine of the data, and at the same time is the cosine of the negative data. But the sine, you see the top and the bottom, are going to be opposite of each other. So that will tell you something. And that's going to be the one that, if you consider the cosine of the negative data and the cosine of the data are the same. So the cosine is an even function, but the sine is an odd function because they are opposite of each other. Sine of the data is negative sine. Okay, so this observation easily will tell you that. Note that is very useful for the application. So note that if you consider the sine of the negative data, Okay, sine is the y-axis, you go up and down. So it's going to be negative sine of the data. But if you consider the cosine of the data, negative data, the cosine of the negative data and the cosine of the data are the same. You know that the tangent you divide, so that gives you the tangent of the data. The tangent of the negative data is going to be negative. Okay, negative tangent of the data. So this is the property that we're going to have. Only the cosine are going to be even here. Okay, the sine and the tangent is going to be odd. Cotan is the same as the tan. It's the same thing. The secant is the same as the cosine. But if you know these three, then you'll be able to take care of the everything else. Okay, so you don't have to memorize it. If you get this, okay, this picture, if you like, then you get it right away. So this is it. This is going to be the cosine function, if you like. Okay, the cosine function is going to be even, but if you like the sine function, sine and the tangent functions are going to be are odd functions. Okay, so this is the way we are going to operate. So you may have to find the sum of these values for us. So you got to be careful. Any question? So we may ask you example. We may ask you to find the exact value, okay, of each of the following. We give a couple of them on the test, each of the following. So if you've been asked, what is, for example, what is the sine of, okay, the sine of negative 45 degrees. Just think about this picture that you have. It's up and down, the sine on the y-axis. So the solution is going to be, the solution is that the sine of negative 45 degrees is equal to the negative sine of 45. And you have the 45 from the table, so they give radical 2/2, and you're done. Okay, so be prepared for it for the test. Any question? Check another one. Another one, you may be asked, what is the cosine? Okay, what is going to be the cosine of the negative? Okay, negative 2 pi third. It's a cosine. It's a cosine. The cosine is going to be the same. So the solution is going to be, the solution is that the cosine of negative 2 pi third, we can drop the negative sign. So it's the same as the cosine of the 2 pi third. 2 pi third is going to be 120. You go to the table and you find it. Okay, you know, 120 is the same as, if you like the reference angle, is going to be the same as the 60. It's the second quadrant. So the cosine of the 60 is half. So this is going to be negative 1/2. And you can get it from here. This is a 2 pi third and the negative 1/2. Okay, just pick the one, but you have the table and you can do it. It's going to be negative 1/2. Okay, so the cosine of negative 2 pi third is going to be negative 1/2. Okay, any question? So get to know them. We like these negative angles, and from time to time we are going to see them, so we don't mind to have these, okay, these type of expressions. Okay, we give you an expressions and we would like you to to be able to evaluate it for us. Okay, so I'll give you that example. We have it on the practice one, so I'm going to check it. You always have some difficulty for this problem in calculus. Okay, so this is one of the problems that you will see on the, let me just bring it up because I want to make sure that you get this one. Okay, so this is the one that we posted for you. This would be one of the problem, one of those 11 problems on the test. We check this one for you. Just changing these numbers. Okay. This problem is from, you can use the table. Okay, you use the table, but you have to do something else for us to get these numbers. So make sure you are able to handle this problem. This is problem number 14 on the practice one. Very important problem, okay? This is the only thing you do really in calculus for us, over and over and over. So example, this is number 14. Okay, number 14 on the of practice test number one. Even when I post that take-home quiz for you, take-home quiz is the one that you do it for your, okay, to practice. Remember, it's 2 points, but you better do it because that gives a model for the test. Okay, now what is this question? The question is that if the angle theta is equal to the pi 4, 45 degrees, okay, then we would like you to evaluate the following. We check everything on this one. Evaluate each of the following. Okay, each of the following. These are the type of functions that we are interested in for calculus. Okay, this is it. The first part is cosine of theta. Okay, we may write it down in function form or just as is. The first one is cosine of theta. You just substitute, you plug in and you get the numbers, okay? Theta is pi 4. This is the way you write it down. You say cosine of the theta is the cosine of the pi 4. You go to the table, no calculator, remember, table only. Because they say exact probably, yes. No calculator, we give you the exact. Evaluate, okay, the exact value of each. So that give a radical 3 over 2. And you're done. Okay, unit circle table only. Any question? That's the warm-up. Okay, part B. Part B is cosine cubed. Cosine cube of theta. You see, you substitute first. So the substitution would be cosine cube of theta is cosine cube of what? Substitute pi 4. You see, it's like something like parentheses to the third. This is the way you have to think about it, okay? You better rewrite it. It's like cosine of the pi 4, everything to the third. You see, this is the way you think about it. Cosine of the pi 4, everything to the third. So now what we are going to do is we substitute cosine of the, it's like order of the operation. You do inside parentheses first. So cosine of the pi is going to be radical 2 over 2 cubed. Okay, you have to simplify it. You know that you can radical 2, you can write it down in this format, would be easier to handle because when it's a square, you are fine. Remember, no calculator. You want to see your algebra. Okay, radical 2 square would be 2. Okay, 2 square would be 4. 4 now times what? Radical 2 over 2. That's the best way to simplify. Now the 2 and 2 would simplify. That give you 1. So the result is radical 2 over 4. So the cosine cube of theta is radical 2 over 4. No calculator, exact value. Any question? So order of the operation. Some people, when they do this one, they made a mess on this one. You see some people, they even multiply these 3 by pi, 3 by 4, or sometimes they find okay, they do something it's quite different. If this is just the order of the operation, something raised to the third. It's exponential expression. Exponential expression, you have to take care of the base first. The base is cosine of the pi 4. Find the base, raise it to the third, and then you're done. Okay, any question? And we have it in calculus quite a lot every day. And some people, they make a mistake, so we want to make sure we know it. The next one is interesting. All the possibilities are here. Doesn't mean that we give you all of them, but we have everything we need. So what's the next one? You see, the next one is cosine of the 2 times theta. You see, this 2 is not a power this time. It's just a coefficient, multiply. This is exponent. This is just 2 times theta, 2 times theta. So substitute. So what we have cosine of the 2 theta is equal to, okay, it's going to be cosine of 2 times theta, 2 times, what is the theta? Theta is pi 4, 2 times pi 4. Okay, continue, simplify it. You see 2 and the 4 would be simplified, so that give you cosine, okay, cosine of the pi half. You go to that table, you find the cosine of the pi half, which is 0. You see this is the pi half. Remember, the first one is the cosine, the second one is the sine. Cosine of the pi half is 0. Okay, so the answer is 0. Any question? So the cosine of the 2 theta is going to be equal to the 0. Okay, so the first one was exponent. The first one was the exponent. This one is a coefficient, just multiply. Okay, question? Let's see, what else do we have? That was a multiplication. Now, how about the kind of division or part D? Part D, they ask what is the cosine of? Okay, the cosine of 2 theta third. 2 theta third, again, you have to substitute. You substitute your data by 4, simplify it, and then you go to the table and give the leftover. So what we have is cosine of the 2 theta third is going to be equal to, is the cosine of, it's like cosine of 2 third times theta. If you like to write it down for an easier form, you see this is what it is. 2 third times theta. But what is theta? You see this is 2 third. The angle is pi 4. So it's a times pi 4. Times pi 4. Okay, cosine of the 2 third phi. 2 third theta, the theta is pi 4. Now simplify it a little bit, you see. The 2 and the 4, we can simplify it. So simplify this one, that would be 1, 2 times 3, 6. So it's going to be what? It's going to be cosine of the pi 6. You go to the table. Cosine of the pi 6, pi 6 is 30 degrees. You see, pi 6. Pi 6 cosine is the first one, radical 3/2. So that give you radical 3/2. Okay, so the cosine of 2 theta third is going to be radical 3/2. Any question? So be careful, you do the inside operation first, then you come back. Inside was 2 third times theta. You see, 2 third of the theta. This is it, 2 third of the theta. Of means multiply. So 2 third times theta, then we substitute, simplify, and come back to get your result. Okay, any question? What else? The next one. The next one is opposite angle, if you like. This is cosine of the negative theta. we talk about it. Data is an even, cosine is even function. Remember the cosine of the positive data and negative data are the same. That was the one. You see, remind yourself if you like. That is, this is it. That is the data, and this is the negative data. Cosine is the same. So the cosine of the negative data is, you substitute first, of course. So the solution is going to be, this is it, cosine of the negative data is going to be, data is negative pi 4, pi 4. So it's going to be cosine of the negative pi 4. And this is going to be the same as the cosine of the pi 4. And the cosine of the pi 4 is radical 2 over 2. I knew that. Okay, so we take care of that negative part first, if you like, and then we get the answer question. And we have one more. Okay, all the possibilities, pay attention to this one. It's such an important one for any future application of these ideas. Okay, now part F. In part F, this is what we have. We have a cosine squared, you see. We have cosine square of the 5 data, all of them together. Okay, you have the exponent, and at the same time you have a, okay, you have the exponent, and at the same time, if this is going to be the case, okay, cosine square of the 5. So let's do it. So this is going to be cosine square of the 5 data, which is equal to, okay, just substitute cosine squared 5 times data, 5 times pi 4. Okay, that gives 5 pi 4. You cannot simplify it. So it's going to be cosine squared of 5 pi 4. Okay, but it's like what? It's like cosine of the 5 pi 4 all squared. Okay, we find the inside first, then all squares. 5 pi 4 is 225. Okay, but you have it on the table. You see this is 5 pi 4. 5 pi 4, so the cosine and the sine, negative radical 2 over 2. So you find it from the, okay, no calculator, but the table is fine. And so it's going to be negative radical 2 over 2 all squared. Okay. Now negative square would be positive, radical 2 squared would be 2, and the 2 squared would be 4. So the result's going to be 1/2. So cosine squared of the 5 data is equal to the 1/2, and we are done. Okay, this is the way we are going to take care of, you know, this operational format, if you like, of a function that we needed. We give a very mild one on the test. Most of you did all right. That was just 30 degrees one. Remember, it was question, I think, number 3 or 4 on that. But this time it's going to be a little bit more involved of this format. Okay, all the possibilities, the power, the coefficients, so that you are ready for it. Okay, so we put all these ideas of algebra in this function really to ask you to get these numbers. Okay, there is another operational one. I'm going to explain that one too for you because we are in the application of the table. Any question? Number 13 is another one, a big, okay, a big angles. So let me explain that one too. Okay, so this is going to be number 13 of practice or on practice test. You have the solution, you can check it for yourself again. Number 1. So we give you a couple of these angles, and then we want to check. The angle are big, and most of them are on the unit circle table, but you may do a little bit to get it. Okay, we want to find the exact, no calculator, remember. You can use just the unit circle. Find the exact, okay, exact value of each function, of each expression. Okay, let's see. Example, the first one is well known. Okay, it's a cosine of 300 degrees. We want to know, how you check the table or how we're going to find it. It's going to be the same thing. Okay, so you can use the table right away, or it's 300 degrees. You can get the reference angle of 60 and take care of it if you like. Without any table, but we don't mind. This is it. 300 degrees is here. Okay, we want to know how you read this table. So the sine is 1/2 and the cosine is negative, okay, radical to the half. So the cosine is negative radical to the half. And we accept that because we give you the table. Okay, any question? So this is the way you answer this type of question. Don't use your calculator, because if you use your calculator, give me lots of decimals. But they say exact. Exact, you just read it from the,
Is
okay,
it, isn't
read
that
it
the
from,
sine, Professor?
is
Or
it sine? No,
Yeah,
it's cosine.
backward.
On the practice, it's cosine.
okay.
I think so. But it would be easy to find both of them, but and that is what it is. Okay, so that's first part. The second part is, okay, what's going to be the second part? So the second part is the sine of 5 pi, okay, 5 pi third. Again, 5 pi third, it's going to be pi third is going to be 60. It's same thing, it's 300s. Okay, it's a 300s, but this time is the sine. It's the same as the sine of the 60, but it's negative. So it's going to be negative, okay? It's going to be negative 1/2. Okay, no, not cosine of the 1/2. Yes, it's going to be 1/2 only. Okay, it's a negative 1/2. Okay, this is 5 pi third, 5 pi third, and you are interested in cosine, the first one. Yes, it's a 1/2. Cosine is positive. Thank you. Okay, but make sure write it down 1/2. Okay, just reading these tables. Any question? The next one, it's a little bit more. You want to find cotangent. We give you something that you have to find it yourself a little bit more. Okay, this is 450 degrees. Okay, this is it. Now you know that you have only 360 degrees, so you have to go around the circle. Okay, 300 to get to the 450. You have to go one more. Okay, this is what would happen for you. Okay, so this is going to be the case. So you go around the circle once, that give you, okay, that give you 360. Okay, then you come to the, okay, you come to the pi half over here. That give you 450. Okay, 450 degrees. Or if you like, 450 degrees is 360 degrees plus 90. So it's kind of reference angle is 90, and the 90 is in the first quadrant. So everything of the 450 is the same as the 90. Okay, so and this is it. You claim that the cotangent of, okay, cotangent of the 450 is the same as the cotangent of the 90 degrees. Okay, you know that. You have to find the tangent after the tangent of the 90 degree is going to be, see, this is it, the tangent of the 90 degrees. Remember, it's a sine of the 90 degrees over the cosine. You have to both numbers here is going to be 1/0, which is a kind of infinity or undefined. Okay, but the cosine is the other way around. So the cosine of the 90 degrees would be 0. Okay, if you switch it, that gives 0 over 1, which is going to be, if you like, it's 0 over 1, which is equal to 0. So the final answer, the cosine of 90, the cosine of 450 degrees is going to be equal to the 0. Okay, so they may give you something cosine secant, so that you have to you do a little bit more for us besides reading that table. Okay, any question? So we are not going to do quite a lot. There's going to be a couple of them, but look at this number D. In number D, they ask for the cosecant of negative 135. You should know that the cosecant is the reciprocal of the sine. You can bring all the formulas to the test, we don't mind. If you feel uncomfortable to memorize it, okay. So you have to know that the cosecant of the negative 135 degrees is the same as the 1 over the sine of negative 135. But in the case of the sine, remember the negative would come outside. It's going to be 1 over minus the sine of 135. Remember, the cosine of the negative data is the same as the data, but everything else, you just have to pull out that sign. Sine of 135 in the table, it's a negative radical, it's a positive radical 3 over 3. See, 135. The sine is radical 2 over 2. So this is going to be 1 over negative radical 2 over 2. Use the reciprocal, it's going to be 2 over radical 2. You have to multiply by the radical 2, the top and the bottom. I write it down here, cosecant of negative 135 is going to be negative 2 radical 2 over 2, because you multiply the top and the bottom by the radical 2. So that gives me negative radical 2 as you get a cosecant. Okay, so you have a secant of negative 5 pi 4. You can check the solution yourself. So be ready for it. We give you one question, a couple of these ideas, but you use the table, but you may have to, this negative sign especially is going to be around for all of them. So you may have to know to take care of that negative to be able to do it for us. Okay, any question? So again, we focusing on the function part of this type of problems, if you like. Now, what we are going to be interested in, we are going to be interested to pick one of these functions. Okay, and let's start with the sine and check some property of the sine, like in calculus or in algebra. If a function is given to you, you should find out what is the domain of this function, what is the range of this function. Okay, what's the graph of this function? This is what we're going to do. Okay, so the sine and the cosine are the most popular one for the application. We focus on those two. Okay, then we talk about the tangent. If you get the time, we talk about the others, but you must know the sine and the cosine at least, okay, to get through these or applications. So let's go back and introduce that. Let's start with the sine. Okay, what's going on with the sine? It's a nice function, very nice function, many applications in science, and we give a very nice method to take care of all the ideas of the sine functions. Okay, so I'm going to check only one section of this chapter. Let's see how far we can go, and it's going to be sine function, sine and a cosine. Okay, so let's check the property of the sine function. Okay, what is going to be the sine function? The sine function. Okay, the sine function y equal to the sine x. That's a sine function. Or f of x equal to the, it doesn't matter. Or f of x, or f of x equal to the sine x. Okay, this is going to be the one that we're going to be interested in. Okay, so we give you some properties step by step. So you know that we just getting these functions from the unit circle. Okay, so what is going to be the properties of this sine function? Okay, so let's see what is properties of the sine function. Sine function. Okay, the first one is the domain. You know that we define it. We start with the unit circle. Okay, in the unit, sorry, we start with the right triangle. We would be able to just talk about the acute angles. Remember, then we get to the unit circle and use the idea of the radian to be able to define the x for anything you like. Remember, if you give me any number, I go on the circle, I get this one as a, okay, the arc length, then I can define it for you. So the domain is all real numbers. Okay, so the domain of this function, domain R, or d equal to, okay, negative infinity and positive infinity. That's the domain of the sine function. Okay, no restriction. No restriction, you can use any number you like. Some numbers, of course, are nice, but if there is not going to be a nice number, you can use your calculator, okay, to give us a domain. Now, the important part for calculus is the second one, the range. You see, remember the domain is x. You drop the x into the sine function, you click on your calculator, we get the result. Result is the range. You know that the unit circle function, you see this is here. So that is the sine function. Remember, for the sine, you go up and down. Up and down, the radius of this circle is 1. So you can go up to the positive 1 and just, this is going to be kind of, okay, this is going to be a positive 1 over here, if you like, and this is going to be a negative 1 here, and it's going to be the same up and down here. So you go up and down to the negative 1, positive 1. So this is it, you see, and the sign is going to be always the sine x, because the sign is y on this, this is the radius, is always less than equal to 1 and greater than equal to the negative 1 for all x, for all x. Very important property, again, in the application. So if somebody say the sine x is equal to 2, find the x, you say, what are you talking about? The sign can be only between negative 1 and 1. Okay, so this will tell you that the range of this function. Okay, so the range of this function is between anything between negative 1 and positive 1. So that's going to be, okay, the range of the sine function. Okay, so the range is going to be, okay, this is it. So the range of this function, the domain is going to be all real numbers, okay, but the range is going to be between negative 1 and 1. Okay, any question? That's the second property. What's going to be the third one? We already talked about it. You see, if you are going to be on the top, it's positive. If you go down the bottom, it's going to be negative. So remember, it's an odd function. The sine of negative x is going to be equal to the, okay, negative sine x. That's it. So the sine function, okay, the sine function, okay, is odd. okay, is going to be odd. When you are going to be in algebra, this means the graph of function, as so and so. If you don't call it algebra, you know it. Otherwise, we graph it, we say it. This means if you go to the right okay, it's going to be the origin is going to be, okay, it's going to be symmetric with respect to the origin, if you like. The sine function is odd, and so the graph of its graph, if you like, the graph of y equal to the sine x, this would be useful for us, is symmetric. Symmetric with respect, okay, with respect to the origin. That will help us when you want to graph it. That would be very useful. Okay, so this is going to be property number 3. Now, what's going to be the next property? The next property is, remember those reference angles that we talk about it. If you go around the circle, it's a 2 pi. But if you have a number which is greater than 2 pi, then you come back again. You see, remember, for 405, if you like, it's 360 plus 45. So when you go around the circle once, you get back to whatever you had before. So after one cycle, this function would repeat itself, if you like. If you have a function that would repeat itself after a while, if you like, we say this function is periodic. And that number after repetition is called the period of the function, okay? And that would be very useful for us to be able, okay, to graph it. So this is another famous property of the sine function, okay? We can get back to the, okay, original one. So the sine function, okay, the sine function E is going to be periodic, okay? It's going to be periodic with the period, with the, okay, this is it, period. We usually write t equal to the 2 pi. T equal to the 2 pi. So this means, so if you want to find the sine of, okay, a sine of x plus 2 pi, you get back to the sine again. And that would be very useful. If you go around the circle once, so for the leftover, you have no other choice. You get back to the original one, you see? Because you have to be here. You see, this would repeat itself after 360 degrees. So if you want to find 405, 361st. Then 45. This is 45. Okay, 390 degrees, 361st. Then an extra 30 degrees. You get back here. So that will help us when you want to, to graph this function. Okay, so the domain is going to be all real numbers. The range is going to be between -1 and 1. And it's periodic function. So this means you get to get this information only for one cycle between 0 and 2 pi. If it's going to be anything else, you can, you get back to the original one. So this is going to be 1. And the other properties that I'm going to write is good for the, okay, graphing these functions. You know that in algebra, anytime we want to graph, we find the x and the y intercepts. Okay, so we replace the x by 0. We get the y. That's easy. If we replace x by 0, sine of the 0 is 0. Okay, so you can say that the sine of 0 is 0. And so this point, okay, the origin. So 0, 0 is going to be, okay, I put the x equal to is the y-intercepts, is the y-intercepts, okay, of this graph. of the graph of y equal to the sine x. Okay, so this means this is where the graph of the function would touches or crosses at the y-axis at the origin only. Okay, now how about the other way around? So number 6. Number 6 is that if you want to know for what value of x the sine would be 0, then if you go to the table, you will see it. This would be 0 at 0. Okay, this would be 0 at 0, at pi, at 2 pi, okay, 3 pi, etc. Even you can have positive or negative, okay? And if you like negative pi, you know that because of the sign of negative pi is negative sine of the pi, and this is going to be, okay, negative 2 pi, negative 3 pi, etc. So these are going to be your, okay, so the x-intercepts, of the graph of y equal to the sine x are going to be x equal to the 0, positive negative pi, positive negative 2 pi, etc. Okay, and you will see them in a minute when we, okay, when we graph this function. Any question? Since the range is negative 1 and 1, the maximum value that you can have is 1. The minimum value that you can have is a negative 1. Okay, so the number 7, since sine is between 1 and negative 1, then the 1 is the maximum value at most, maximum value, and negative 1 is the minimum value, the minimum value of y equal to the sine x. That will help us quite a lot to be able to graph it. Okay, any question? Now we can graph it. You can collect some points, in mathematics if you want to graph it at some point, but we give you a quick way to do this graph of the sine function. You see, look at this quick method. See? Such a good one. You can do the most complicated one. You see, remember so what is going to be that's number 7, number 8, the graph of y equal to the sine x is going to be given by the following, if you like, by the following. Now, I can get some numbers, but I want you to see how you do it in calculus. You see, look at that period that we have. The period was 2 pi. You see, if you graph your function, you will see that, if you want to pick some numbers, if you like, to pick some numbers, let's show this some numbers, then I give you a shortcut. You see, I want you to believe it, but you don't have to do it for the test. You see, x, y equal to the sine x. So the period is 2 pi. So you have to go with, so your x is going to be between 0 and 2 pi. So you have to pick some numbers, like in algebra. So what I do, I pick some easy numbers. I put x equal to the 0. The sign of the 0 would be 0. I pick x equal to the pi 6 because that's easy number. The sign of the pi 6 would be 1/2. Then I pick the pi half, which is easy number, that give me 1. Okay, then I can go and get some other numbers. Okay, for example, 5 pi 6, that give me 1/2. Then I pick the pi, that give me 0 again. You see, these numbers won't be repeated. Then I keep going. I pick 7, 5, 6. Again, that give me 1/2. Okay, I come back and I pick the 7 pi 2 pi half. That give me -1. And I just keep going. Lastly, I get the 2 pi, which is going to be 0. You see, if you locate these points, this is all you are going to get. Look at this one. You are interested in one period, 0, 2 pi. You divide, you see, you get 0, 1/2, 1, 0, 1/2, 1 again. So you divide this one into 4 parts, 4 equal parts. That's it, 2, 3, and 4. Okay, now identify it. If you divide, this is 360 degrees. If you divide it by 4, so that give you pi half. That give you pi. This is going to be 3 pi half and the 2 pi.
Question.
Yes.
7 pi over 6, shouldn't it be -half, not half?
5 over 6, no. Because
7 pi over 6 should be -1/2.
no, 5 by 6 is 150. Must be positive. Because pi 6 is 30 degrees, 5 times 350. It's positive I have. 7, you mean 7?
That's what I said.
Yes. Oh, you said 7, sorry. What is that one? That would be 2. Okay, yes, it's 210. You are right. Thank you. Thanks. Very good. Okay. Now, let's see what we do. You see, we divide this one by 4. So even you can identify these numbers if you like. But what would happen really over here is this function, you know that can go up to the 1 units, down up to the 1 units. So the maximum that you can go is here, a positive 1. The minimum can you go is here, is a -1. Okay. So your starting point must be from 0, 0, 0. So you start from here. Okay, you start from here. As you can see, the numbers would be up. 0, we get to the 1/2, then we get to the 1. Then we come back. So what will happen for you is, you see this function, then you come back to the, you see that's it. 0, 1/2, 1, 1/2, 0. So what you do is, this is the maximum that you can go. So from here, you go to the maximum. Then you get to the intercepts. Then repeat it again. You go down. You go down to the minimum. You go down to the minimum. And then you go up. This is going to be the graph of the sine. If you put these numbers exactly, you get, whatever you have here to get those numbers. You see the pi 6, pi 6, 1/2, this is it. Pi 6, 1/2. So that give you this point here. 5 pi 6, 1/2, that give you 5 pi 6, 1/2. So basically, whatever number you pick for the sine, you divide this function into this region into 4 parts. You see 4 parts. 1, 2, 3, 4. So you start from the 0. You go up. You go up to the first part. You always give you the maximum. Then you get the intercepts. Get the intercept. You're intersecting the x-axis. Then you go to the minimum. You go to the minimum, then you go to the maximum, which is 2 pi, and then you're done. That's easy function. We are going to make it complicated in a minute. But that would be very quick. And this is the method that we like. So what we did really is we are going to divide this one into 4 intervals for calculus. You see the interval that we have here going to be, you start from the 0, pi half. Then you have the pi half, pi. Then you have the pi, 3 pi half. Finally, you get to the what? 3 pi half and the 2 pi. You see, each portion is 90 degrees. Each portion is 90 degrees, and if you start from the 0, you must get to the 2 pi eventually. So that's basically what we are going to do with the sine function. Because it's not always going to be sine x. You may be given sine of 2x, sine of 5x. Okay, if you want to use these type of ideas, things getting complicated. But this is in one period, you see. If you want to repeat it again, you see, you can repeat it again over and over and over. That gives you, you see, if you want to extend it, you see, suppose you want to extend it to the negative. So this is a negative 2 pi divided by 4. Okay, that give you the 4 parts. Okay, so this is going to be negative pi half. This is going to be negative pi, negative 3 pi half. So what's going to be your function? You see, you go down first. You go down to the minimum, down to the minimum, then to the intercepts, then to the maximum, then to the intercepts. This is another period of the function. And you can go on forever because this function is periodic. It's just going up, down, up, down, up, down to get all these numbers. That's the best way to do it in calculus 1 and 2 and in 3. We're going to use this type of ideas. I'll give you a break. If we come back, I'll give you more example on this one. Okay. And we are not going to give you the cosine, which is very similar, but we'll give you the cosine after your test. And then we go over those numbers. Okay. Any question? Of course, you know, you can use numbers if you like, but this is the way we suggest, because in future, you know, quickly we'll be interested in just one portion of this graph when you are in calculus, and these methods give you very nice one. Okay, so I come back and give you a couple of more examples, and we focus on this one. We are not going to give you the cosine, would be too much. Okay, any question? It's almost 7:30, 10 minutes. We come back, give you a couple of more examples, and we go over some of those problems on the practice one. We give you the test up to this part. Okay, 10 minutes, and I come back. Okay. I'm going to give you more examples of the sine function. We talk about sine x, okay? But we are not going to have sine x all the time. Okay, we may have sine 2x, 5x, okay? So we have to modify this information. Okay, starting from this one. So for example, if it's going to be 2x, so we can call 2xz. If it's going to be sine z, the period is going to be 2 pi. But if 2x is equal to the 2 pi, so x would be what? Would be 2 pi divided by 2. So we have to modify this one, okay? So I'm going to write it down in a more formal, okay, form, if you like. And then we give you various possibilities. Because when you are in physics, okay, chemistry, engineering, the function is going to be, you may get sine of pi x, sine of pi half x. So how are we going to take care of those? These are the ones that we are going to be interested in, okay? And so we give a remark. And we introduce the function that's going to be used in science, if you like. So we're going to pick a number, a coefficient. We're going to give a coefficient to this x. So let's have a positive number. Okay, so suppose b is a positive number, if you like. B is going to be a positive number, a positive number. Okay, a positive number, and okay, and a function. If you like, f is defined by, this is going to be our function. You see, f of x is equal to, we have a number here, we call it a. Okay, we call it a, and this is going to be the sine of bx, if you like. In your book, this is again a capital B, but let's just write it on this form. Okay, the sine of f of x equal to the a sine of bx when a is a number. When a is a number. Okay, then what's going to be the period of this function? Okay, the period, if it is z, for example, if it's x, the period is 0 and 2 pi. After 2 pi would be repeated, but this is 2 pi would be in this case, okay, bx is equal to the 2 pi. So you want to find the x. So x would be 2 pi over b. So if it's going to be any coefficient, it's going to be the 1. Then the period, then, because the period is going to be important for us, okay? The period of the function is t is equal to, okay, it used to be 2 pi, but you have to divide it by this new coefficient that we have here, okay? It's going to be 2 pi divided by b. Okay, it's clear because whatever it's inside, that must be between 0 and 2 pi. It's a b times x between 0 and 2 pi, or b times x is equal to the 2 pi, so that x, that period would be 2 pi over b. Okay, that's going down 1. So that's a period. Any question? We are going to change the range again. Range, remember, when it was only sine x, you go up positive 1, down negative 1. Now there's a number here. If this number is going to be 2, you go up positive 2, negative 2, 3, negative 3. Okay, we have a special name for this one, especially in application in physics. Okay, and this is it. We're going to say that, or note that in this case, what is going to be the situation we're going to have? Okay, so in this case, what we have, remember the sine of bx is going to be between 1 and negative 1 range. But if you multiply by a, that gives negative a less than or equal to the a sine of the bx, which is going to be less than or equal to the a. So as you can see, the range of your function, you see this is going to be the range of your function. So the range of your function is going to be between a and negative a. So the range of this function is going to be closed interval of a negative a and a. It's clear. You see, when it is sine is between -1 and 1, okay? Between -1 and 1. So in this case, you are going to see, okay, negative a and a. Okay, so it's not a big deal. We know it, but this number in physics, they call it, okay, the expression is the, I think this is the way we are going to pronounce it, amplitude, okay? Amplitude, if you like, this is it. Amplitude of the function, okay, is defined by in those format, they introduced by W, okay, or just the absolute value of A, if you like. So we call it omega or W, which is going to be absolute value of A. Okay, so if it's positive, that's going to be exactly the same number. If it's a negative, you change it. In the problem of your book or the problem that's given to you, they ask you to find, when the function is given to you, they ask you find the amplitude and the, okay, and the period of the function, and then graph it. So means you identify this range, and then you're going to graph your function. Okay, so for example, this is it. If y is equal to the 3 sine of 2x, okay, if this is going to be the case, then the period of your function is going to be what? Is going to be 2 pi over 2, which is equal to the pi. Okay, and a is equal to 3. So that amplitude is going to be just 3. Okay, so it's not a big deal, and the period is the one that we have to find it all the time. Okay, now that will help us or give us a chance to give you a better graph. Okay, the graph that we are going to use in applications. Okay, any question? We just extended that idea. You can stay with the one that we talk about it, but things getting complicated. But in this format, quickly you can graph the function. It would be so useful, this method. For, there are different methods to do it. This method is short, so useful, if you want to take calculus. So this is the question that we are interested in. Example, we want to sketch the graph. Sketch the graph of each function. Okay, of each function. Okay, let's try this one. Let's say call it number 1. Okay, how about y equal to the 3 sine of the 4x. Okay, quickly identify the period. Solution. You see the coefficient is b is 4 if you like. If you like, b is equal to the 4. So the period of the function is going to be 2 pi over 4. Okay, 2 pi over 4. You simplify that, give a pi half. So this means you have to arrange it. You see the value of your x must be between 0 and pi half, one period that we're going to have. And the range of your function, okay, is going to be what is going to be the y, and the y is going to be between -3 and +3. So this is the most. You go up and down, and you get the pi half. Okay. Now the shortcut that I talk about it. The period that we're going to graph this function for us is 0 and pi half. So I explain it. You know, you do it the action right away. I just explain this one. Divide 0 and pi half. Okay, 0 and pi half into 4 sub intervals. You see, this is the way you do it. I explain this one, then I do it again. For the other one, we do it right away. You see, this is 0, and this is pi half. You divide it by 4. What's going to be this one? Divide by 2, 3, 4. What is going to be each portion here? You see, pi half divided by 4. What's pi half divided by 2? Pi half divided by 4. That gives you pi 8. So pi 8, pi 8, pi 8 to get to the pi half. So this is going to be 0 and pi 8. Okay. Another pi 8 here. Pi 8 plus pi 8 would be 2 pi 8. I write it down, then I simplify. 2 pi 8. Another pi 8 here. That gives it 3 pi 8. 3 pi 8. So what are those intervals that we are going to be interested in? See, this gives you 0 and pi 8. That give you can write 2 pi 8, but you simplify it. That give pi 4. Pi 4 and 3 pi 8. Oh, I'm sorry, I missed it. Yes, I missed one of them. 0 pi 8, pi 8 and the 2 pi 8. You see pi 8, and 2 pi 8. And the 2 pi 8 would be pi 4. Okay, 1, 2, 3. 3 is going to be pi 4 and the 3 pi 8. And the fourth one would be 3 pi 8 and the pi half. You see? These intervals are very important in calculus because these are where you are going to get the maximum and the minimum of the function. And the application, in application case, we are interested in these, we call them boundary values. Okay, so it's nice if you have those type of ideas for future, to think about it in this format. Okay, so basically you just find the period first. The pi half, that give one period. One period is going to be between 0 and pi half. As I talk about indicator of the sign is going to be, see, up, intercepts, down, intercepts. So you have to break it into 4 parts to see those type of, intervals. And to be able, to do it quickly. I just did it here so that you can see it. But otherwise, you don't need anything else. Any question? This is actually what would happen. You don't need anything, no calculator, nothing really. Such an important method. We do the same thing in pre-calculus when we teach, and I usually teach this method because it's very important for calculus. Your book is a good one, they talk about it. Okay, do the same thing here. This is 0 and pi half. Divide into 4 parts. Okay, this is it. Divide it into 2, 3, 4. And you have to label this interval for us on the test. Okay, label it. Pi 8. 2 pi 8, which was pi 4. 3 pi 8. You see, 4 pi 8 would be pi half. That's it. How far you go up and down? -3 and +3 because amplitude is 3. Okay, so identify up and down. +3, suppose this is 1, 2, 3, +3. Okay, 1, 2, 3. That is going to be -3. Okay, this is where you go up and down. Okay, it's a sine function. You know that the sine starts from the origin. Start from the origin is go up first. You get the maximum at the first boundary points. Then you get the intercepts in the second boundary point. Then it's go down. Go down, you get the minimum here. Minimum here. Then it would be intercepts. Okay, up, down. You see, up to the maximum. Down to the intercepts. Down to the minimum. Up to the maximum. Up to the intercepts. This is it. This is the graph. All the graphs are the same. You see, the graphs are very similar, but these are going to be, the shrinking, it's going to be different. Sometimes you expand it, sometimes you shrink it. You see? So the boundary points are important for us. We find out that at the pi8, the function is maximum. What is the maximum value of your function? 3. At the pi4, over here, we get the 0. So the value of the function starts from the 0, that's going up to the 3, then come back to the 0. Then it's going down to the what? Going down to the -3 at 3 pi 8, and then going up to the 0 here. So that gives you good idea. It's in one period. If you want to do it in 2 periods, you can continue getting these numbers up and down. Okay, any question? So those crucial interval that we talk about it is going to be very important, and you get these points. And these are the ones that you are going to use in calculus in future. Okay, the coordinate of this point is going to be 0, 0. Then over here, you get a pi8 and the +3, the maximum. Okay, intercept, etc. And you're done. Very easy method. Any question? So we like this method. You see, you can graph it, just bring a collection of points. Okay, make a table. So what? You get at the end the same thing. And this method is going to be very popular. Any question? I'll give you another one. These are the type that you see in physics, okay, or electrical engineering. If you do those type of problems, okay. So this is the second function. The second function is going to be, you have y equal to, okay, this is it. Let's have y equal to the, okay, it's a 2. It's very similar to one of those numbers that we have. 2 sine of -pi12x. You can make it as complicated as you like. We can do it for you. You see, when you are in application, you get these type of coefficients. pi4, pi12, okay, those type of numbers. So first thing to do, we are going to take care of this negative sign. Remember, we talked about it in case of the sign going up and down. When there is a negative inside, you pull it out. So that will help you quite a lot. So that's your first job. Solution. We rewrite it as y equal to -2 sine of the pi12x. If it's happened to be cosine, that we do it after your test, that negative would disappear. Okay, identify the period. So what's going to be the period? B is equal to the pi12. Remember, the period is going to be 2 pi over b. What's a 2 pi over b? It's a 2 pi, and it's going to be pi half. It's like two fractions. If you divide two fractions, you write the first one, multiply by what? Reciprocal of the bottom. Pi half would be 2 pi. Pi and pi cancel out, you get 4. So the period is 4. So the interval that you're going to graph this function for us is going to be what? Is 0 and 4. So what you do is you divide it by 4. This is 4. That period is 4. If you divide it by 4, that gives you 1. We always divide by 4 because we know that in the case of the sine, you saw that what would happen into the 4 subintervals. So this means this is the way we're going to break it. Okay, this is it. The period you are interested in 0 and 4, 0, 4. So you divide into 4 parts. The length of each subinterval must be 1. You know, you see it. When you divide it, automatically you will see it yourself. And so this is it. You divide it by 2. So that gives you 2. You divide it again. So that gives you 1. And that gives you 3. 0, 1, 2, 3, 4. Any question? We always divide by 4 because we know that this is what would happen for the sine. Okay. Now, how far you are going to go up and down? The number is 2. It's a negative 2. You know that amplitude would be the absolute value. So 2 up, 2 down. So this is how far you're going to go up and down. So we identify that this is going to be a positive 2. And you identify over here, this is going to be a negative 2. Okay, a negative 2, and you know what to do. You start from the, okay, you start from the origin. So you have to start from here. You go to the, you know, for this point, you are going to have a maximum, for example, to get these numbers. But this one is interesting. What is interesting about this one? Look at the coefficient. The coefficient is a negative 2. So when it's a negative, when you want to start, you are not going to go up. If it's going to be positive, you go up to make that maximum. But when it's a negative, you have to go down. So we start from here this time, you see? We start from here. So in the first point, you are going to get a minimum. Okay, so you get a minimum. Then you go to the intercepts. At the next point, you are going to get the maximum. What's the maximum? The maximum would be here. Okay, because this is going to be a positive 2. So we get the maximum. Then we have to go to the intercepts. This is going to be the intercepts. So this is going to be the graph of your function. Any question? So make sure don't miss it. Okay, don't miss it because the starting point depends on the direction of your function. For the other one, this coefficient was positive, but there was a negative inside, so we have to pull out that negative one out, and that would, okay, so that's the way we do it to get these numbers out. Okay, any question? So it's the only point that you have to consider, otherwise it's very easy graph. With this method that we're going to have. Okay, but make sure to identify these numbers for calculus. This number is going important. We have 4 critical intervals, we say 0, 1, 1, 2, 2, 3, 3, 4. In the first part, we get the minimum. The minimum value is negative 2. We get it at 1. In the second part, we get the maximum. The maximum value is going to be 2, and we get it at x equal to 3. And if you want to do it more, you just continue, okay? You can go on forever to get these numbers, okay? The cosine is almost the same, but it's not going to be a start from the 0 because the cosine of the 0 is 1. So we have to start from the top. We talk about the cosine after your test. So we're not going to give a cosine on this one, okay? Because we want to give enough time to go over some of the problem on the review. Okay, any question? So check this method. It's just very easy method, and you have all the information that you need. It's nothing that you don't have it. We have a couple of them. Number 15 on the practice one. We can check it. We check the part B. Okay, no cosine. We can just give one question, and we give you two of this sine function. So make sure that when this coefficient is positive, you go up first. When it's negative, you have to change the direction going down. Okay, make sure it's consistent. So let's explain one of these of the number 15. There is a number 16 on the solution that I gave you. I just drop it. That's application type. We give you that one after, after your test, but you have those solutions. But I drop it because it was too many. Okay, so this example is going to be number 15 on the of the practice test. One question would be this graphing. Okay, I do the okay. We are not going to do the cosine. So check the part B. Okay, very similar to what I did, but it's there is a difference. The difference is your function is y equal to the 2 sine of a quarter of x. Okay, so it's going to be the 1. So the angle, so the coefficient is b is equal to a quarter. Okay, so you have to remember, you have to get the period first. So this is it. So your b, the coefficient is a quarter. There's going to be always a coefficient. We are not going to give, of course, sine x. Okay, b is equal to the quarter. So we are going to find the period. Period is going to be 2 pi over b. So we get a 2 pi and the b of a quarter. Use the reciprocal of the bottom. So it's going to be 2 pi times 4 over 1, which is 8 pi. Okay, so the coefficient that we're going to be interested in is going to be, okay, so the t is equal to 8 pi. And the interval that's going to be interested is going to be 0 and 8 pi. Okay, so you have to divide into 4 parts. And so this is it, 8 pi divided by 4. That gives you 2 pi. You will see it when you distribute it or partition it yourself. Okay, so this is it. Okay, so this is going to be the case. So what we have, the period 0 and 8 pi. So it's going to be 0 and this is 8 pi. Again, you have to partition it. Divide into 4 parts. This is it. You divide it by 2. So that gives you 4 pi. And you divide by 2 again. So that gives you 2 pi. And you know that's going to be 2 pi, 4 pi, 6 pi. So that's going to be 6 pi. Okay, 0, 2 pi, 4 pi, 6 pi, 8 pi. That's 4 important intervals that we are interested in. Any question? What is the amplitude of the function, range of the function? You see the a is 2. So 2 up, 2 down. So that's it, up to this point. This is going to be 2 down. Get this one a negative 2. Okay. So your coefficient is positive. You see the amplitude is positive, the a is positive. So we go up first. Okay, you go up. So the first one give you the maximum. Then this is going to be the maximum, the intercepts. At that point, give you the minimum. Okay, sorry, this is 2. So that give you the minimum. Sorry, I missed it. This is the minimum and then the graph. Okay, so this is it. You go to the, okay, this is it. The max and the mean, and this is going to be the graph of your function. Okay, not a big deal, but everything is clear. See, so nice. Everything is clear. The interval 0 to pi, 2 pi, 4 pi, 6 pi, 8 pi. The maximum value happen at 2 pi. It's true. You see, you don't have to go and use your calculator to find it. You already got it. See, that's the advantage. Already you know that if you put x equal to 2 pi, you get 2. Or if you put x equal to the 6 pi, you get negative 2. So you don't have to check anything. And that give you the, the answers. Okay, so it's a nice one. Any question? So check the one that we have. Okay, no cosine, not a big deal, but I want to give you a little more time to, to think about these numbers. Okay, any question? So the one that you have on the review, the part that you did on the quiz, we are going to repeat it. Remember, we defined these trigonometric functions using different ideas. Using the triangle version, now the circle version, you are free to use whatever method you like. Okay. So we give you a couple of questions on these. We have it here. So there's going to be 2 types. I'm going to review those 2 for you. Okay, so number 9 and number 11. Okay, so let's check this to make sure you understand what we expect you to do for us. Okay, any question? So get these numbers and you should be able to get excellent grade on this test, really. Okay, let's see. So just to remind you that how we're going to give us those trigonometric functions. So that's a practice test. Again, you have the solutions, but we just want to remind you a couple of topics. Number 1, we give you 1 question of this group. You see that's the number 9. The information that we have is this. We have the sine of alpha is equal to the 4/5. And you'll be given that the alpha is between 0 and pi half. This means alpha is in the first quadrant. Okay, so alpha is going to be in the first quadrant. Okay, this is it, the first one. Then you have another one, you have the sine of the beta. You have the sine of the beta is 513. 513. And you'll be given that this is beta is bigger than pi half and less than pi. Between 90 and 180, this means, where is this one? Okay, so this is going to be in the second quadrant. You need this information, you know that. Then they ask you quite a lot. What is tangent of alpha, cosine of alpha, secant of alpha, 1 by 1 to get these numbers. Okay, so you can use the right triangle version if you like. Okay, or just the xy coordinate. Both of them are going to be the same. Okay, so this is it. What do you want? For example, you want to find the tangent of alpha. Tan of alpha. So you check to see what we have. We have the sine of alpha is equal to the 4/5. It's in the first quadrant, so we can use the right triangle version easily. Okay, this is it. And this is going to be your alpha. So you have the sine. You know that sine is what? Sine is the opposite over the adjacent, over the hypotenuse. Okay, so we can find these numbers quickly. What is this number? Any suggestion?
3.
3, very good. You know that 25 25 minus 16, 25 minus 16 minus 16 is equal to the 9. So this number would be 3. You complete this triangle right away, okay, automatically. Now we are ready to give you the tangent. So the tangent is the first quadrant. The tangent is what? Opposite adjacent. So this is going to be the 4 over 3, yes. Any question? So that's a 10. They ask for the cosine of alpha. Again, what's the cosine of alpha? Cosine adjacent. Okay.
It is 3 over 5.
3 over 5. That's a cosine. Okay. Part C, they ask for the secant. You must know that the secant is what? Reciprocal of the.
Secant reciprocal of cosine of sine.
Okay, it's reciprocal of the cosine. Okay, the cosine is 3/5. 1 over 3/5. You flip it, 5/3. Okay, so that's going to be secant of the. These are with the alpha. Now they ask for the beta. So part D, they ask for the cosine of the beta. Now we have to take care of the beta. Is you see what we have is the sine of the beta is equal to the 5 over 13. You got to be careful. And this is in the second quadrant. You see, you are here. When you are here,
only sine move.
yes, the sign is positive, so cosine is negative. So be careful. You can use the right triangle version when you want to do it, okay, but use that negative sign. So if you want to use the right triangle, this is it. So we have the sign 513. You get this number?
Yes.
What's the number?
169 minus 25.
169 minus 25.
Yes, 144.
144, which is
12.
12 squared, yes. It's 12. So this is 12. Okay, now, if you want to stay with this one, you see this is the way you do it. Cosine of the beta. You know that the cosine is negative. Is the negative of 12 over 13.
Yeah.
You see, this is the way we do it. If you want to stay with this, just make sure that you don't miss those signs. Cosine is negative. So we can use the right triangle version, but apply the negative sign first. Any question?
No.
So that's a cosine. Then we have the part E is secant. Secant of beta. You know that the secant is reciprocal of cosine. We already got the cosine. So it's a negative of 13 over 12. And then we're done. Okay, any question? Part F is cotan. Cotan of beta, okay? So you better find tangent first. And remember, you are in the second quadrant. The tangent is negative. Because this is negative, this is positive. Positive,
yes.
Negative, negative. So we use the tangent of beta, but we write the negative sign first, then opposite adjacent.
Yes.
512. Okay, but you want to cotan the reciprocal. Okay, so the reciprocal of the tan would be cotan. So this is the way you operate for this type of number for us. Okay, so we give you one of them. It's going to be a kind of 2 parts because we check one acute angle, then the other one is we want to check to see how you follow the signs. Okay, So it's going to be something in the second quadrant, the third or the fourth for that, for that second part. Okay, that one version. Any question? The other version is the point version. Remember, a corresponding point would be given to, that point would be corresponds to the angle in question, and you want to do it. This is number 11, and the same one that you did on the test. You did have this one. So let's remind you, number 11. So a point would be given. Okay, we can check one of them. You have both of them. Let's check the second one. I think you have some radicals maybe. And that's it. So the point on the terminal side of the angle is given to, you want to identify the 6 trigonometric function. Okay, you know that when it's a point version, they didn't say that this is going to be right triangle or unit circle type. So what we do, you are going to call it X and the Y. Okay, we call it X comma Y. Okay, so that's it. So you compare, you get your X is equal to 2, your Y is equal to the -3. Quickly, you have to find the R. Remember, R is equal to the square root of X squared plus Y squared. And this is going to be 2 squared plus a -3 squared, 4 and 9, radical 13. Since they say exact, remember, you are not going to use your calculator. You write it down as is, okay? Because they want to check your algebra. And that's it. Now we can write the formulas regarding, with the corresponding point to find the numbers. So there you are, the sine of the data. Sine is on the y-axis, YR. Okay, the y is -3 and the r is radical 13. You cannot leave it. You have to rationalize it. It's a -3 radical 13 over 13, the correct answer. Okay, again, no calculator. Any question? Cosine. Cosine is on the x-axis, it's going to be x over r. Okay, x over r, and the x is 2 and the radical 13. So that give you rationalize it to radical 13 over 13. So that would be the cosine. You divide to get the tangent. Okay, y over x if you like, or you divide. So that give a -3/2. This is this function. Use the reciprocal to get there to get the others. Okay, cosecant of the data is negative radical 13 over 3. Okay, secant is going to be radical 13 over 2. And finally, cotan is going to be -2/3, and then you're done. Okay, so typical problem that we did before, and we repeat it again. These are all each one of them, each section that we did, and we introduced this trigonometric function. Okay, any question? So that's the second concept that we're going to be interested in. Now, getting back to the these ideas of the radian and the degrees. Okay, so we give you something to convert from one, go to the other one. You just check number 1, 2, number 3. This is the one that you did on the test. Number 4. I want to make sure I get able to.
Number
okay.
9, teacher.
Number 9.
Yes.
I did number 9.
Oh, yes.
Yeah, let me explain this important one first, then if I get time, I go to the other one. Just make sure to get this number. Number 5. Number 5, we are interested in true notion. We are interested in the area of the sector and the arc length. Okay.
Number 6.
Yeah, it's a 5 and 6. Okay, number 5, area of a sector. Okay. You want to find the area of a sector of the radius. Okay. We are interested in area of a sector. You must know the formula, area of a sector. 1/2 r squared theta bat in radian. Don't miss it. Some people, they miss that one. So
Yes.
if the angle is not, if it's in degrees, you have to change it.
To change it to rad.
Okay, so it's a straightforward. The radius is given to is 3, okay, 3 meters. And the central angle is, okay, the central angle is 120 degrees. You have to change
Yes.
the radian. Okay, so this is it.
V
D180 r pi. You substitute 120, 180. Okay, r pi. You simplify as much as you can, and then simplify by 60. That give you 2/3, and the r pi. Cross multiply. R would be 2 pi, 2 pi third. 2 pi third. Okay, so that's a data in radian. Then you just substitute. So the A is equal to the 1/2 r 3 squared. 3 squared times 2 pi third. It's going to be 1/2 times 9 times 2 pi third. You simplify it. So that gives it 3 pi. But you have to, replace the pi by 3.14 to give us the final answer.
Oh, yes.
Okay, so it's going to be 3 times 3.14. Okay, so that's going to be 12, and this is going to be 4, and that's a 9. You have to give us a measurement. It's a square meters because that's the area problem. Okay, any question? So that's a sector, area of a sector. The other one we are interested in is the arc length. Okay, because more of them are going to be used, in calculus or other courses that we're going to have. That's why we check it. Any question? So make sure to remember the area of a sector, the formula. Remember, you have to change this one into the
To
radian
radian. Yes.
and not use the degrees. Okay, now for this number 6 for the arc length, we pick
We have
this.
to change also the.
Yeah, we pick this, famous problem. You know that we live on a, what's that? A spherical or ellipsoid is going to be the Earth, and then the cities would have these locations. Okay, so if this is going to be Earth, if you like, okay, and the location of 2 cities are given to you, what is one is going to be Memphis, Tennessee, and the other one is due north of New Orleans. You find the distance between the Memphis and the New Orleans. Okay, so this is the one. You see, that's the center. So these are given to you in these measurements that you usually use. Okay, so this is going to be one of them, if you like. That's going to be the first city, which is, okay, we have a 35 and 29. You see, this we get to both of them, you see. This is what we have. So the first one we have for the 35 is Memphis, okay? So this is going to be kind of, we can call it data 1 if you like, and the second one is going to be data 2. Okay, so the data 2 is equal to 35 degrees. Okay, the 9 minutes, and the data 1 is going to be 29 degrees and 51 minutes. So the distance in between, okay, is going to be, you have to find the difference. You see, this is the distance that we're going to be interested in. Distance between the 2 cities. Okay, so this is theta 2 and this is theta 1. This distance is this one. Okay, this is the arc length. So it's like, you have the arc length. This is going to be the arc length in question, and this is the angle data, if you like. So the angle data is a difference. Okay, distance between the city is going to be the S, if you like. Okay, the arc length. And remember, the arc length formula is, what's the arc length formula? S equal to R times data in radian. So that's going to be the, the arc length formula. That's the arc length formula. So the distance between the cities would be just the arc length that we're going to have. So what we're going to do, we have to find the data first. Then change it to the radian. You have the radius of the Earth is given to you. Okay, 3,960. Okay, so this is it. So the radius is given. This is going to be the I think it's miles. So that's the one. So what we're going to do, we have to find the data first. You subtract these two. Okay, you are going to subtract. You have the 35 degrees, 9 minutes, and this is 29, and the 57. We cannot subtract it. We have to borrow for the top. So we borrow this one. We make this one to 34 degrees, but this is going to be 69. Okay, 69 minutes, and this is going to be 29, and this is going to be 57. Okay, you subtract it first. So that give you 2 and 1, and over here we get the 5. So the data is going to be 5 degrees and 12 minutes. Okay, so you have to change it. Yeah, we have to change it to the degree first,
Degree
and
and
then
radian.
then we change it to the radian. Okay, to change it into the degree, you know that this is going to be, we have the 5 and we divide it over 60. Okay, that give you 1/5. It's going to be simplify it. So that give you 5.2. Okay, you simplify that, give 1/5, which is 0.2. So that give you the data, which is going to be 5.2. Okay, now you change it to the radian, and then you substitute. Okay, so it must be in radian. So d over 180 equal to the r over pi. Then you substitute. Okay, and this is going to be r over pi. So we simplify it. Eventually, r would be 5.2 times pi over 180. Okay, I'll give you the number is, you just substitute 3.14 for the pi, so that give you the r. So this is going to be your data in radian. Okay, so the data in radian is going to be this number, which is 0.9, is a 0.0907. Okay, so now we can go back and get the arc length or the distance between the cities. So that give our data in radian. So the R is 3,960 times 0.0907. Okay, that give you 359.2 miles if you run that. So the distance between the cities is going to be 359 miles. Okay, so that's an excuse to talk about the arc length, really. Okay, so we emphasize that one of them would be given to you. Okay, so the other, that the collection, change. We give you one question, just changing into the, this radian, degrees, minutes, etc. It's going to be only one question, but you will get one on the arc length and the area of a sector, which is very, very important. Okay, any question? So refresh your memory, make sure you don't miss it. It's an easy problem, okay, but interesting to get these, those values. Those application problems are both interesting and easier to handle. Okay, so that so for 1, 2, 3, 4, those measurements, just check the solution that I posted for you. Make sure that you have no difficulty. So that will take us to the number 7, find the exact value. you can use various tools. Okay, so this is number 7. We talk about it. We give you some of these numbers, but it's going to be, number is big. You can use some idea to show you some idea to simplify it, or just find it right away. Find the exact, again, no calculator. You can only use the unit, okay, table, circle table. And if the radicals involved, just write it down in radical format. Okay, let's remind you the suggestion, for example. So, for example, you want to find the sine of, okay, sine of 11 pi half. You can calculate it if you like, but you see, if it was something like, okay, if it's what 12 pi, 12 over 2 would be 6. Remember, the sine is periodic. If you go around the circle, you can forget about those multiple of 2 pi if you like. So one idea is it's 11 pi half. So I can write it down as, okay, it's going to be what? It's going to be 12 pi half minus pi half. But 12 pi
Yes.
half would be 6 pi. You know that you can forget about the 6 pi because the sine is periodic. You go around the circle 3 times, the reference angle would be, you see, it's going to be the sine of, it's going to be the sine of the 6 pi, sine of the 6 pi minus pi half. So you can forget about the 6 pi because it's repeated itself. So that gives the sine of negative pi half. And we talk about it for the sine. Sine is an odd function. You can pull out the negative sine of pi half. So it's going to be -1. Okay, so just find it for us. Use any method you like. You can count it if you like. Pi half is 90 degrees, so times 11 would be 990 degrees. And to be able, you know, you have to take out those 2 pi or 360 degrees to shrink it, to get the reference angle. That's the idea. But this is the way you do it. Okay, when the number is big, shrink it. Any question? So that is for the A. We haven't talked about those, but you know, we can do it. Cosine of 7 pi, for example. You know that again around the circle 2 pi. So it is going to be a cosine of 6 pi plus pi. Again, you can forget about the 6 pi. So it's simply cosine of the pi, which is -1. Okay. So that is going to be again reference angle or the periodic one. The next one is easy. You can check it from the table. 7 pi 6 tangent of 7 pi 6 pi 6 is 30 is 2, okay, 210, and you can check it. It is going to 210. It's going to be like a negative tangent of the, okay, pi 6 if you like. Okay, but you have to find the sine and the cosine to get this number. But pi 6, if you remember it, that is 30 degrees. So that gives a negative radical 3/3, I think. This is going to be, you know, the result. It's in the, what's that? Third quadrant is positive, sorry. The tangent is positive. 210, you see 210. This is it, 7 pi 6 and 210. You got it here. Okay, and that's a sine and a cosine. If you divide it, that gives you, okay. If you divide, that gives you radical 3/3. Remember, you divide the sine by cosine. So that is, or you can bring your table for, we give you the table, remember, for 30 degrees, 60 degrees. So we can use those ideas again. Okay, and This is the tangent. The next one is a secant. So part D. Part D is a secant of, okay, secant of 3 pi 4. 3 pi 4 is 135. So we need the cosine. So quickly we can find the cosine of 3 pi 4, 135. So you can use the shrink it to the pi 4 if you like, or just use the table. 3 pi 4. 3 pi 4, remember this is the cosine and this is the sine.
Yes.
So the cosine is negative radical 3 over 2. Negative radical 2 over 2. Then use the reciprocal to get the secant. So the secant of the 3 pi 4 is going to be negative 2 over radical 2. Again, you have to simplify it. You multiply by the radical 2. So that gives you 2. So it's a negative radical 2. Okay, so the secant of the 3 pi 4 is going to be equal to the negative radical 2. Okay, so that's the idea of these, we want to see how you read those tables for us, okay? Table, how we're going to shrink those numbers to get the result. That's a number 7. Any question? Number 8 is the same thing, but they ask for all the functions, okay? Find the exact. So that's number 8. Again, you can use the table. Okay, let's try one of them, number 8, part 1, 8 pi 6, 8 pi third. Okay, that is going to be 8 pi third. You can shrink it if you like,
Yes.
because the pi third is 60 degrees. So this is 400, okay, 80. So it's too much. You can shrink it, you can divide it. If you divide the top by the bottom, okay, so this is going to be like, okay, if you divide it, there's going to be leftover. This is going to be 2 pi, 2 times 3, 6. And there is going to be a leftover, 2 pi third. Okay, because 8 third is going to be what? You see 8 third? 8 third is 2 and the 2 thirds. That's what you got. So this means, okay, everything would be the same as the 2 pi third. The trigonometric function of these two, when you shrink it, because it's a 2 pi, you can forget about the 2 pi and go for it. So for example, if you want to find the sine of the 8 pi third, it's going to be the sine of, I write one of them, 2 pi plus 2 pi third. Okay, 2 pi plus 2 pi third, which is going to be the sine of 2 pi third. Okay, the sine of 2 pi third, use the table and you get it. Okay, it's in the second quadrant and it's the same as the 60, 720. So that give you radical 3/2. Okay, so this is going to be the first part. Any question? Cosine of the 8 pi third. You got to be careful. It's going to be again cosine of the, okay, cosine of the 2 pi third. You check the table, it's going to be negative 1/2. The cosine is negative in the second quadrant. Okay, then the rest are going to be followed. The tangent of 8, you divide. Okay, we have the sine and the cosine. So the tangent would be negative radical 3. So these are those 3 famous ones. Use the reciprocal to get the others. Okay, so cosecant of the 8 pi third is going to be, you just use the reciprocal of this one, 2 over radical 3. So it's going to be 2 radical 3 over 3. So that's a cosecant. Secant, easy. secant would be a -2. And the cotan. Cotan is going to be 1 over -1 over radical 3, and that gives you negative radical 3 over 3. Okay, so it's easy problem. Any question? The second one is 405, which is like a 45. That's very easy. You know, the second part, you should check it. I just show you that. You see the second part is much easier. 405 degrees would be 360 plus 45. So the reference angle is 45. So you have all the information for the 45 right away. You see the sine, the cosine. So that give you the numbers, okay? So these are give you the idea of the type of question we have. Number 8, 9 we did it, 11 we did. Okay, 12 again is similar to the other one. I explain it. There is one point about 12. Okay, question. So 12, the sign is given. You want to find the other part of the this trigonometric function, but this is number 12. Number 12. Part 1, we have the sine of the data. You see, we have the sine of data is 12 over 13. Information is that the data is in the second quadrant. Okay, that's easy. Is in quadrant 2. Okay, remind yourself that what's happened in the 2. In the second quadrant, is it in the second? Yes. You are in the second. Okay, sine is positive, so you remember that the cosine is negative. Okay, so what we do is we can easily go to the right triangle version. Okay, this is it. And this is going to be your data. We have the sine. What is the sine?
Yes.
Opposite 13. What is this one?
Mm.
13 is
I
square.
think 25, 30, 5.
Yeah, it would be 5. It's correct.
Yeah.
You know that 100 and see 13 is square. It's 169 minus 12 squared, 144, which is 25. So this would be 5. Any question? Pythagorean identity, you know that we use it right away. Now we are ready to list all the information that you need. So the sine of the data is already 12, 13. Okay, the cosine, be careful, cosine is negative. Okay, in the second quadrant, the cosine is negative. So it's going to be negative of the cosine. What's the cosine? Cosine is adjacent over the hypotenuse. Okay, the tangent, you divide these two. So that give me negative 12 fifths. Okay, and the rest reciprocal. Cosecant, 13, 12. Secant, 13 fifths. Cotan, negative 5, 12. And then you're done. Okay, any question? So again, now make sure those signs, you know, right triangle version fine, bad, sine. Make sure your sign is going to be consistent. The second part, there is one point. We talked about this one before, but it's not bad to remind you. Okay, what's special about this one? We have 10 of data is equal to a 3/4. Okay, 3/4, but the sign of data is negative. You have to check to see where is this data, which quadrant. Any suggestion? The sine negative, tangent positive. Where are you?
In the third.
You are going to be on the
In the
in the
third.
third. Yes, it's right. Tangent is positive. Tangent is positive. Sine is negative, so cosine must be negative too. We are here. Okay, we are here, so the cosine is going to be negative. Remember that this is important because when you want to write it on, we need this sign. Okay, so because negative would be positive for the sine. Okay, for the tangent. So go to the right triangle. Okay, this is going to be a theta. You have the tan opposite 3, adjacent 4. Okay, what's this one? Hypotenuse.
5.
5, yes, 5 is correct. Because you know there's going to be 9 plus 16. 9 plus 16, which is 25. So it's a 5. Very good. Okay, now we are ready. We got to be careful. We need a sign, but we know that the sign is negative. Make sure to apply the negative sign. Negative. Okay, the opposite is 3 and 3/5. That's the sine, cosine. We know that the cosine is negative. Okay, it's going to be negative, adjacent. That's it. The tan is already given. Okay, use the reciprocal to get the others. Cosecant of theta negative 5/3. Secant of theta negative 5/4. And the cotan of theta is 4/10. And then you're done. Okay, so these are all the possibilities that you need to know. That's it. Any question? So we did all of them. Just check your quiz. Okay, check your quiz and this one. But you have everything you need on this. But check your quiz. We didn't have any, on your quiz, for example, we did have one problem in solving the equations. Remember, solving the triangle. When those right triangle would be given to you, just refresh your memory, make sure you are ready for it. The question would be repeated too. Okay, but otherwise, okay, that's it.
Professor, we don't have any homework assigned.
No, I'm going to update the assignment, but
Okay.
but we don't collect any homework assignment on the day of the test.
Okay.
And the assignment will be collected on the day of the quiz only. Okay, so you are going to have this one, and I don't remember whether I post the take-home quiz or not. So I check it, probably not. So I post one for you. It's going to be take-home quiz. If you, I think I didn't post it yet. That will help you. It's if you bring it in, we get 2 points. But you don't have to. But it's good. It's good for you to practice because we have 1 week. So I want you to, I want to get another practice before getting, to this one. Yes, the take-home quiz are going to be due on the day of the test. I posted on the canvas, and then I give you the deadline and everything on that one. That would be easier. Okay, so make sure that study this practice one first. Okay, study this practice one first, and then when I post that take-home one, that give another chance to practice before before the test, and then you'll be fine. That's it. Any question?
How long is the time limit for the test?
For the test, we give 2 hours.
Okay.
Oh,
Yeah, 2 hours for the test, but for the quiz, we cannot give you more than 1 hour because But test 2 hours, yes, 2 hours, and we give you 1 hour lecture because we have to do something on that day. But I think by the 2 hours, you should be able to do it. Okay, so just that's it. Any question, any concern, just email me, and make sure you should get 100% on this, on this test
Mhm.
really. Okay, so be careful. Okay,
I don't think it.
that's it. Okay, any question?
No. Very good.
So have a good fun. Any question? Okay, thank you. Have a good one and take care.
Thank you.
See you
Teacher.
next week. Okay, thank you. Bye bye.
Thank you. Have a great day.
Bye bye.
Bye.